We talked about the parts of a parabola, and we'll kind of review those a little bit right here. If I were to draw a parabola like that, we have this point, which is called the vertex. The line down through the middle is called the axis of symmetry, the AOS. Okay, there's a line down here and a point up here. This point here is called the focus point. And this line down here, however far away this point is from that focus point, that's how far it is away from the directrix. And so I'll just draw it down here. And again, I'm not very good at demonstrating this to scale, but the idea is that those two things are equal to each other. Okay? And so this line down here is called the directrix. And then there's a chord that runs across here that's called the latus rectum. That's what this is right here. And it's perpendicular. There's lots of chords run through there, and those are called focal chords. But this one's a special one. It's called the latus rectum. Now what we're going to do today is look how, and then we talked about what the equations look like. If it was y equals ax squared, it opens up if a is greater than 0. It opens down if a is less than 0. Or it could be x equals a y squared, which means it opens to the right if a is greater than 0. It opens to the left if a is less than 0, meaning negative. So we're going to look at a couple examples of how we find those parts, the different parts of this, and sketch the graph of it. So we're looking at an example like y equals negative 1/16 x squared. We want to be able to find which way does it open, what's the vertex, what's the axis of symmetry, what is the focus point, what's the directrix, and finally, what's the latus rectum. And the key to finding these is there's a couple little formulas, really all just based upon this value of a right here. Which way it opens, we already know from up above here. Since it's y equals and a is negative, we know that it opens down. So that we know that it opens down. Okay? The vertex on all of these is going to be 0, 0. So that's just a given. There's shifting of these things, but in this situation, we're not going to cover those. The axis of symmetry is this vertical line then that goes through that point. And so at this point, I usually just start graphing it. I know the vertex is right here. The axis of symmetry is this line right here. Well, this line has an equation. If you remember, a vertical line has an equation of x equals, and in this case, x equals 0. And so you would write x equals 0, not just 0. It's an equation, so it has to be an equation with x equal, or if it's sideways, it'd be y equals. To find the focus point, what you do is you find out what is 1 over 4 times a. And so to do that, that's how far away the focus point is in the direction that it's going. And so what I usually do is just find out what is 4 times a. 4 times negative 1/16. And if you simplify that, you get negative 1/4, right? What we want to do then is take 1 over that. So all I do is find that, and I flip it over. So if I flip this upside down, this equals negative 4 then. So from the vertex, I'm going to go down 4 units. If this opened up, I'd go up 4 units. If it opened to the right, I'd go to the right 4 units. If it opened to the left, I'd go to the left 4 units. So because it opens down, I'm going to go down 4 units. 1, 2, 3, 4. There's where the focus point is. So I know that my parabola opens down. Focus point's always inside of the parabola. So if it ends up not that way, you're going the wrong direction. Okay? The directrix, so what is that point? Well, that's the point 0, -4, and that's what I want you to write down there. To find the directrix, you go that same distance, but you go the opposite direction that you went to find the focus. So I'm going to go up 1, 2, 3, 4 in this case. And it's this line right here. Well, this is a line. A line has an equation again. Just like x equals 0, y equals something here. And in this case, y equals 4. That's what the directrix is. To find the length of the latus rectum, what that is 1 over the absolute value of A. And that's how long this chord is down here. Okay, that's the total length of it. And so if A is -1/16, the absolute value of that is a +1/16. So 1 over 1/16. And all you really do is flip this over, so this length equals just 1 over A. So just A flipped upside down. And it's positive. It will always be a positive distance. So that means this whole chord across here is 16 units long. Because it's symmetrical, it has to be the same length as is here. So all I do is take this, divide by 2, and I can go 1, 2, 3, 4, 5, 6, 7, 8. Put a point right there. Go 1, 2, 3, 4, 5, 6, 7, 8. Put a point right there. And now I can kind of sketch in my parabola. And I know it looks like that. So we just found all of the parts to it just based upon the equation. All right? So again, the key to it is the focus is 1 over 4A. The latus rectum is this. And the directrix is just the opposite direction you went for this. Okay? So let's look at the one that goes sideways now. Let's take a look at x equals 1/8 y squared. Okay, so again, what we want to find is we want to find which way it opens, the vertex, which we already know is 0, 0. All of these that you're going to be doing at 0, 0. The axis of symmetry, the focus point, the directrix, and the latus rectum. And again, it's all based upon this right here. So if it's x equals, that means it opens in the x direction. So I know it's going to open sideways. Because this is positive, it's going to open in the positive x direction, so it opens to the right. The axis of symmetry. So let's start graphing it. I know that the vertex is 0, 0. Okay? And I know it opens this way. The axis of symmetry then is this line that goes through that in the direction it opens. That has a horizontal line. It's y equals 0. It's always just the opposite of whatever this is. If this was y equals, it'd be x equals here for the axis of symmetry. Okay? For the focus point, remember we do 1 over 4a. So I take 4 times a. 4 times 1/8. If I do that, I get 1/2, right? And then I flip that over. So I'm going to go 2 units. So that 1 over that is 2. That's how far I'm going to go in this direction from the vertex. So 1, 2. There's my focus point. The directrix, I go the same distance, but the other direction, 1, 2, and it's perpendicular to that axis of symmetry. It's that line right there. And because it goes up and down, that's an x equals, and at that point x equals, oops, I screwed up. I didn't write in the focus point. Let's find the focus point. So that point right there is the point 2, 0. All right, I got ahead of myself. For the directrix, we go to the other direction, 1, 2, draw the line perpendicular to it. This is the directrix. That's an x equals -2. Latus rectum, we take A and we flip it upside down and make it be positive. And so this would be 8. From the focus point, I know this chord, because my parabola opens this way from one side to the other, I know it has a total length of 8. So I'm going to go 1, 2, 3, 4, half of that up from the focus point, and 1, 2, 3, 4, half of it down. And now I can sketch in my parabola. And I found the parts, and I sketched the parabola. Okay? That's the idea behind it. Just one other example that there might be is the equation might not always be nice and pretty like this. It might actually be y minus 1/8 x squared equals 0. And what you have to do is the thing that's not squared, oops, sorry about that, y minus 1/8 x squared equals 0. The part that's not squared, either x or y, that's what you want to get by itself. So y is going to equal 1/8 x squared. And now we can go about, because it's y equals, it opens in the y direction. And we can find all of the parts for it that way. That's what your assignment's on today. Hopefully that's clear. Let me know if you have questions.